Welcome to the Fire Sprinkler Podcast with Chris and Logan.
Sprinkcad for Revit, now with fabrication tools. Quickly generate complete branch lines with armovers, sprigs, or drops. Connect heads to branches, generate heads on runs, or pipes to pipe with any desired fitting, even on sloping pipes. Design, calc, fabricate. Sprinkcad.
Hey everybody, thanks for tuning into this episode of the Fire Sprinkler Podcast. On this episode, I have Rob Smith from JCI. Rob is a Sprinkcad. Would you call yourself a guru? What would you call yourself in regards to the Sprinkcad software?
I wish I were a guru. I might be in the position of directing a lot of what happens.
Okay.
But that doesn't mean I understand it. I try to explain to programmers what I want to happen. I try to listen to customers to understand what they want to happen.
Right. What is your position at JCI?
Title is Senior Software Analyst, which basically means that I try to take apart the processes, put things down on paper in a way that programmers can understand exactly what we want to happen. So if you click on a button and you want a certain thing to pop up and you want it to do something, I have to try to describe that. That's
Right.
my primary role. I also back up the technical support group as needed, but generally speaking, they know what they're doing and they do a good job. And then I do listen to customers. We've got opportunities now and again to sit and listen to input from people. In fact, I'll put in a plug right now that anybody that goes to that sprinkcad.com website, there is a sales demo button. You can't miss it up on the top right, big orange thing. And if you click that and you can see instructions on how to send us an email, tell us what you need. You know, I really want to know what people need out of Revit so that we can move in that direction.
So the topic of the conversation today is going to be Sprinkcad for Revit. We're going to kind of see how you go from, the software that was around 10, 15 years ago, and even pen and paper from lines and circles to drawing a 3D product. And I've done other episodes in the past with other 3D design software and kind of gauging my interest on which softwares are out there and using the podcast to my advantage as a very in-depth sales pitch. So like I've said, I've always said I do this podcast in a very greedy manner where I get to talk to some of the smartest sprinkler people in the industry, and
somebody here that I didn't know about. No.
Yeah, like yourselves, the software analyst. That's a title I've never heard before. That's good. You might be the first software analyst I've had on the podcast. Anyways, why don't you kind of bring up the software and show us how it works?
All right. So this is in Revit 2022. We support 2019 through 2022. And I would say that, first off, I'm a software analyst. I am not a Revit guru. We came into the whole Revit world with a whole lot of AutoCAD experience under our belts and not a heck of a lot of Revit experience. And so we kind of dove into this saying, what don't we like about Revit? And to be truthful, there was a lot of things that we just didn't like about Revit. And I think that's true for anybody that has AutoCAD background.
Right.
So a lot of what we did, we tried to incorporate things that we knew how to do, things that we thought an AutoCAD user would be comfortable with. So for example, some of the stuff I'm going to demonstrate right now, it doesn't matter what view you're in, top view, any one of the Revit floor plans, ceiling plans, etc. If you can see the pipe, then you can work on the pipe.
Okay.
So we've got a Sprinkcad toolbar. The BIMport command has been around forever. This was our initial foray into Revit, where we let AutoCAD users who drew in Sprinkcad create fire sprinkler systems and then export them into a special file that this piece of software, BIMport, will read, and it'll literally build a Revit model in Revit using all Revit parts. But it's your design from the AutoCAD side. Now, I'm not going to bother showing you that. We've also got this family manager, and the family manager's purpose is to help you create Revit families from content, such as we've got, sprinkler content, fittings, pipe, mechanical outlets, welds, hangers, valves. You don't have to know how to build families. You just come in here and pick an item that you want to build and say, well, I need to build this alarm valve groove by groove, etc. And you go pick one or more that you want included in that family. Because as you probably know, a family can include many types as long as they share common parameters. So you can go in and you can create a family of something like an alarm valve without really knowing anything about creating families. So that's a really cool tool for somebody who comes into Revit sprinkler design not really knowing that much about. Then we have simple tools like this jog pipe around. Jog pipe around allows you to take, I'm looking at the wrong space. I could take like this sloping pipe here. I'll make a copy of it just so.
Yeah, so what he's
side.
doing right now on the screen for anybody that's listening to the audio version is he's just taking a simple pipe drawing that he's got in the Revit, in his Revit model, and he's kind of showing the different tools that are on there right now. So right now we're going to do the jog around tool. Explain what the jog around tool does automatically.
So what it's basically doing is it's allowing you to establish an angular offset. I need to roll out at 45 degrees, or I need to go up 90 degrees relative to, vertical. I need to go up in the air, go over something and come back down. But maybe you know that you need to go up 2 feet and over 3 foot 4 inches in order to get right into that space that you're shooting for as you slip past some piece of equipment. Well, then you don't have to know the angles. You simply plug into the system that the fact that I want to go up 2 feet and I want to go over, what did I say, 3 foot 4 inches.
3 foot 4, yeah.
And the program calculates the angle for you and tells you what that offset distance is. Or in this top part of this dialogue that I'm showing, you could say, well, I want to go 45 degrees and I want to go 3 feet. So either way, you can describe the offset and the distances. And then you can pick your start and end points, or you can specify from the end of the pipe, go this many feet, and then make my offset, go this many feet further, and then return back down to the original. So I'm going to use that aspect of it here. I'll say, go out 2 feet and come up 5 feet. So I just pick somewhere near the end of the pipe, and the program makes this offset for me.
Does it. So that'll do any kind of angle, up, over, and down at a certain angle. Essentially, you're doing a rolling offset 45 for any fitters that are listening right now.
Exactly.
And does the kind of the legwork for you. Now,
and the beauty of that is that even if that's a sloping pipe, the program is understanding what it does on the slope relative to the slope, and everything that we implement like that, the program thinks in terms of center to center distances the way fire sprinkler people do. Revit has a tendency to think end of pipe to end of pipe, plus you've got this fitting takeout. But our tools work from center to center, so that everything is, the way we tend to think as designers.
And
so
fitters.
That's just, and fitters, that's right. That's just one tool. I come from a design background. I started on the board back in 1980. So for all the fitters out there, my apologies, but that's my background.
Well, the thing that I'm trying to do with the podcast is get the fitters and the designers to kind of
Yes,
think similar, and kind of understand that we're all in the same, we're all in this together. Like, as much
yeah,
as everybody butts heads in the industry, sprinkler and design, like in the field, and designers, like we all have to work together for the same common goal, right? And that's protect property and life.
absolutely. It's kind of like in the movie Oklahoma, where the sheep herders and the cowmen need to be friends.
Yeah. Haven't seen the movie, writing it down. That'll be tonight's goal.
Yeah, well, that's an oldie. That shows my age. So another tool that we have, I'm not going to say along the same lines, but it works whether you're dealing with uh, sloping pipe or not, is the sprinklers on pipe tool.
Okay.
So I'm able to pick a family. Now these families are basically exist in my system, whether uprights or pendants, and I can pick a type out of that family. And then I'm going to take this out and say none right here. And I'm going to go 2 feet from the start of the pipe, and every 12 feet, I'm going to drop a sprinkler head.
Okay.
And I'll say along the entire run. I get options like, do you want to do the full length or not? And I pick that pipe, and the program's going to drop these sprinkler heads along that pipe.
Now, if you're doing something like that and you've already done a rolling offset on it, will it take that rolling offset into consideration? Can it take the rolling offset into consideration, or is it for a length of pipe?
It is for a length of pipe. It understands basically a run of pipe, or if the rolling offset happened in the middle of a run, it could actually jump across the rolling offset, but it doesn't go around and follow through the elbows and things like that.
Okay.
So basically what it did, and I'll zoom in here, is it stuck a sprinkler head onto the bottom of this pipe.
And what you're seeing on the screen here, again, go to the YouTube video, because you're seeing the product, which is, you're not just seeing a line in a circle like a drawing, like a typical drawing is now. You're looking at a sprinkler attached to the bottom of a piece of pipe, which is awesome.
And it's a pipelet, and it did
Mm-hmm.
not break the pipe. I mean, these are true taps. So we use actual taps, actual mechanical tees. We can, do this as a threaded system. We could do it as a mechanical system. This
Yep.
particular operation is responding to Revit's routing preferences. So the pipe type that you see here, Schedule 40 pipe threaded, it calls for welded outlets in the routing tables.
Okay.
And I want to bounce off of that concept of routing tables to say that you don't have to understand routing tables to use our program. That tool I just showed you was kind of an early tool that we implemented. I think it's really helpful, and I could just as easily do sprig ups using the same
Mm-hmm.
tool. And I can specify what kind of pipe that sprig up will be. Some people want to do those with Dynethread, or some people would say it might be a Dynethread branch line, but I'm going to use Schedule 40 drops, for the strength, etc. That's all entirely up to you, because as you saw from the dialogue, I'll just pop that back up. I'm able to choose, especially when it comes to something like my sprigs, what kind of pipe I want to run. So you see there's various, Schedule 10, Schedule 40, JCI pipe that we've created at some point, et cetera. And all of our tools, and the next one I'll show, deal with that kind of, what kind of pipe do you want right here? And even if you don't know anything about routing tables, you can use standard items in order that everything you draw is really based. I'm going to switch back over to a course view for a second so you can see where the sprinkler heads are. I'm going to run the sprinklers to pipe. Actually, I'll run sprinkler to pipe. Biggest difference between these two is when I do sprinkler to pipe, I can specify where does this arm over tie into my branch line. So
Okay.
go ahead.
Yeah, what we're looking at now is another tool, sprinkler to pipe, which on the screen right now he's showing sprinklers that are in that looks like he possibly used some sort of an array tool to arrange the sprinklers into the room.
Mm-hmm.
Did a pipe layout, possibly due to ductwork or something like that. It's a little off center of the sprinklers, not straight off the bottom, not 6 inches, whatever. And this tool is going to do what now?
So I'm basically going to connect those sprinkler heads back to this branch line.
Okay.
And I can either do so with a single intervening pipe, as in a straight sprig or a drop, or I can use an arm over and a drop or a sprig. These are drawn as drops, but elevation wise, you can go up or down.
Mm-hmm.
So the idea here is I need 2 pieces of pipe between my sprinkler and my branch line, the sprig drop and an arm over, or you can go all the way over to a 3 pipe solution, the up, over, down,
Gooseneck.
gooseneck, yeah.
Yep.
So, and in all 3 of these cases, you'll notice if you're looking at the video that we label the drop as A, the primary arm over as B, and if you have that 3rd piece to rise up or drop down out of the branch line first, that's piece C. And so each of those segments has the ability to pick a specific type of pipe and a diameter. So,
Okay. So if you have to rise up with 1.25 inches, over with 1.25 inches, down with 1 inch, if you have, say, a large orifice sprinkler or something and not
precisely.
great water, you have the ability to adjust that.
Absolutely. Yeah. So and I'm going to use these standard pipe types in order to drive home a point. Let me just double check what I'm doing here. The vertical offset. Okay. So that last piece, because I'm in the 3 pipe solution, I
Mm-hmm.
have to specify what's the elevation change between the arm over and the branch line. And do I want that elevation change to be relative to the branch line or relative to the sprinkler? So if you had a condition, as I've seen back in my design days, where I needed to rise up out of the ceiling a very specific distance and hit that zone that was assigned to me, and then arm over to my branch line location and then pop up into the branch line. That's what I would call a down, over, and down, which is kind of
Right.
common in some office conditions, hospitals and things like that. That allows you to say, well, I want to do, it doesn't matter what the elevation of my branch line is now. I want that arm over to be exactly X inches above my sprinkler head. So you can hit that zone that was assigned to you for making the arm over.
Mm-hmm.
Or typical gooseneck situation, I'm just going to go 1 foot up out of my branch line, as you see here. And then I got this little checkbox that says connect to a point on the pipe. The difference is when I use this, the program doesn't just assume a perpendicular arm over. So you'll see that when I pick a sprinkler head, and I can pick anywhere along this branch line. So, sometimes in those, let's call it a retrofit condition or whatever, where the outlets are supposed to be on your branch line, and you've got to get to them in order
Yep.
to relocate those heads. So that's what we've got going on right there. I'm just going to swing that around so you can see what it did. Now, go ahead.
Right. So what we're looking at right now is we're looking at an arm over or a break or whatever you want to call it, your terminology, that instead of coming up and perpendicular to the sprinkler piping, is on an angle to an existing outlet. So if you're doing a retrofit or something like that, existing branch lines or existing outlets are being utilized for that situation, you can use those same outlets as drawn in your drawing and design.
All right, so similar command, except when I use this sprinklers to pipe, or if I didn't use that little checkbox that I did a moment ago, it's basically the same interface. Much of the information is identical, but I'm not able to pick specific points on a pipe because the program's going to let me pick multiple sprinklers all at once,
Mm-hmm.
and then pick the branch line. So that means it has to stay perpendicular. That's the only real point of that.
Right.
And then in this case, it gives me a little report when I'm done as to how many it created. And I should have done a down over down, but as you can see, the sprinkler's there and the pipe basically does what we expected. Everything here was that standard pipe type, except for the original that was drawn. And all of the connections were made using this real basic pipe routing table, which we implement in our template so that you don't have to worry about that either. And the advantage here then is if I say to the program, okay, I'm gonna place a start tag. Now I'm using a command called place start tag, and what it does is it establishes where the pipe begins from a fitting makeup point of view.
Okay.
All right, because everything that we do, if you're thinking fabrication, which is the major aspect of our tool that was released here most recently, was the fabrication piece. The program needs to know direction of makeup. I'm starting here and I'm going that way. So I just placed on this little system a marker. I'm going to also grab a hold of these pipes and say, you guys are branch lines. So on screen, you see a little drop down that shows things like indeterminate, which is the unknown state. And then we have main, branch, rise nipple, underground, arm over. Sprinkcad is very aware of the difference between a main and a branch line in terms of how we number a system.
Right.
Mains tend to go A, B, C, D, E, branch lines go 1, 2, 3, 4, 5, etc. And arm overs and sprigs and drops come into play with other logic. So I'm just going to basically say to all these pipes, you guys are branch lines. That allows me to more easily take this next step where I come in here and say, I want to do a material summary. I pick any one of these pipes and the program says, okay, I found a bunch of stuff. So up on screen right now is this mapping dialog. All right, so long road to a small point. By letting us draw using just pretty much any pipe, and by the way, this will work with anybody's Revit piping systems, as long as they're fire protection pipes. You go in and say to the program, well, I drew this many of something. The program knows the nominal diameters of these pipes and the quantity and their names. And I can say, well, that is schedule 40 inch and a half for me. And that is schedule 41 inch for me.
Okay.
So by identifying it this way, we locked down a couple of different things. For hydraulic purposes, we now know the C factor for wet and dry. We know the internal diameters, the smoothness, etc. We also are nailing down what kind of fittings I expect to get, and that's based on Sprinkcad strategies. So Sprinkcad strategies allow you to set up a set of rules that say, if I'm schedule 10 pipe, I basically want grooved elbows and grooved T's, unless I'm doing, a certain connection type, in which case I want a mechanical grooved outlet. And I want all the outlets for my riser nipples and branch lines to be pipelets. Or,
Okay.
and so all of those decisions are being made automatically by the program. So now I'm going to pick a sprinkler head. These are pendant heads, so I'll just do a quick search on all the pendants and I'll pick one. It's a brass pendant head and say proceed. So the program gives me a material summary. So I'm popped up a dialog that says, okay, look, you've got 5 of these 1/2 thread reducers. You got 10 threaded 90s, 1-inch ductile iron. You've got the reducer fittings, et cetera,
Right.
pipes and sprinklers. And when I say close and say, do you want to update the model? So this is the point at which we move beyond just show me my current material summary and take this drawing that I'm processing and make it look like my actual fittings. And the program says, hey, there's a family that you need that doesn't exist in this model. It's the 1.5 by 1.5 by 1 ductile iron reducer outlet thread T. So I say, yeah, I want to make it. You remember I showed you that family builder previously.
Mm-hmm.
that thing just fired off automatically and made this fitting.
It just made you it just made you a fitting.
It made me a fitting family. And now
Okay.
it's telling me that it's going to replace certain things that are in my drawing, and I say, okay. And so now if I zoom in on things, instead of those temporary fittings that you saw before, we've got actual threaded fittings, threaded elbows,
Looks like a piece of pipe.
reducer coupling. Yeah,
Yep.
it looks like the real thing.
Yeah.
So, and it's got, you've got part numbers and the whole 9 yards. And if we did a different kind of a system, or if I changed the diameter of these pipes, told it it was Schedule 10 pipe, I could get mechanical tees out of this, or pipe-alettes, etc.
Can you go to the point where you're adding, like I noticed when you zoomed in on the sprinkler, it was a pendant sprinkler, so you're not going to have an escutcheon, but can you add an escutcheon at the sprinkler to where when you're picking the list, it'll create an entire list of material you need?
The sprinklers are based on their part numbers, and many of them, like the the semi-concealed pendant heads, they
Yep.
actually come in with a cup that's visible. The I don't want to call it a cover plate, but it's that, it's that recessed cup.
Escutcheon. Yep.
Okay, so yes, I've seen those, and it depends on the sprinkler family.
Okay.
If the sprinkler family includes that, but for example, if it was the old 401 style canopy, which nobody
Right.
uses, I don't think, or a true concealer, I don't believe that the software is currently building the full-blown concealed cup and cover plate with a sprinkler inside. I'd have to double check that, because I have a tendency to just stick with pretty basic heads when I'm doing what I do.
Doing your model. Yeah, that's fair.
But whatever is in our database is going to show up, because everything that our family builder makes is actually coming out of the Sprinkcad database. So that's another point I would drive home, is that it's not just Tyco parts that are in this database. You can add anybody's parts into our database, and you can build that family from anybody's parts.
Okay.
Now, there is a caveat. I want to be plain about this. Part of what you see when I look at an elbow, zoomed in close to an elbow here, there's a sweep, and there are a couple of cylinders. Those three pieces make up the model of that elbow, along with all the Revit pieces that go into play, the connectors and things like that. But a sprinkler head is a much more complex model. As you can see, there are multiple little bits and pieces. If I were to take this out and break it apart, explode it repeatedly, look inside the family, you'd see that there's all kinds of pieces involved. So if you go to make somebody else's valve, somebody else's sprinkler head, a sprinkler head with that escutcheon full-blown concealed canopy, you'd have to spend some time in my database building those individual pieces. But once they're built and they're in there, then you can build families and use them all over.
Away you go.
Or simpler is let the program do what I just did, and then come over here, grab all those sprinkler heads and switch out the families.
Right.
Because it is a sprinkler family, it's connected to the fitting, it knows everything it needs to know about itself. So at that point, I would say, well, there are simpler Revit tools to do what you and I just talked about.
How have you noticed as a designer the change from, say, I won't say pad and paper, but say paper and pen, pencil drawings? You said you started designing in what year did you say you started designing in?
In 1980 with
Okay, that's
with
what
a
I thought
lead
you said,
holder.
but I didn't want to
Yeah,
be a dick and say
yeah.
that.
No, I'm that old. Yes.
I was born in '88. That's cool.
Well, to be true, I started in the womb. So
Oh, well, I'm a third generation sprinkler fitter. If you cut my arm right here, you're going to get sprinkler water that comes out of it, right? That's just, you get black sprinkler
nice.
water. That's the way it
Yes.
works. How big of a change is it to go from pen and paper drawings to software like this that can kind of sense the ideas that you're thinking in your head and kind of create that product for you?
Well, I transitioned to CAD in the late 80s.
Okay.
I started in on computer hydraulics back in like 84, 83. And then the AutoCAD side, I actually worked for the Grinnell company out in Los Angeles, and we started out on a program called GDS, and then
Okay.
that became Micro GDS, and then I got into AutoCAD. So I started working with Sprinkcad in about 1995, I think it was. That sounds wrong, but yeah, maybe it was as early as 94. And I learned then, but I'd already learned the advantage of being able to use that computer to do arrays. The whole concept of erasing through the Mylar was
Right.
gone. And trust me, I had I had worn out a few eraser shields in my time. So I really loved the transition to CAD. I did not ever want to go back to drawing circles, as I called it.
Sure.
Then I spent all these years. In '96, I started working for Sprinkcad. I've been with them, ever since. I moved to Philadelphia in 2001, and I've been here in that vicinity ever since. Um, the transition to Revit, I think, was tougher than trying to learn AutoCAD.
Sure. Yeah. I find a lot of people that I talk to about doing it is and talking to older people as well, is they find going from this little tool, which is like the circle, square kind of tracer that you use for drawing sprinklers by hand if you ever do. They found the transition from pen and paper to computers substantially easier than going from AutoCAD to Revit. And that's, I
Hmm.
would say, probably 95% of the people are having that harder time. The people that are the most successful with transitioning to Revit have completely deleted the old software off the computer and not used it as a crutch. A previous guest that I've had on, Steve Frederick, it was the first person to say that. And then since I've talked to him, multiple people have said, I just kept going back to the crutch of AutoCAD and whatever was, or the
Yeah.
AutoCAD software that I was comfortable with. So I had to delete it in order to make myself, oh, do I re-download everything so I can get this drawing out, or do I just learn to use the damn program that I have loaded right now?
I think I'm in much of that same place because all of my Revit experience has been in this environment of trying to create these tools that emulate an easier way to do things. Now, I really
Right.
do feel like what we're doing is so much easier than the Revit approach. As an example, if you've ever had to draw arm overs, goosenecks from a sprinkler head to a branch line in using straight Revit, the first thing you learn is that the piping that comes up out of that sprinkler head wants to be the same diameter as your sprinkler head or thread size, and
Mm-hmm.
you've got to flip that over. So that was one of the very first things we solved. We said, oh, this is crazy. Why should we have to change that pipe size? So we came up with that ability to say, when I draw this gooseneck, I want 1-inch Schedule 40 pipe right here.
Right.
Um, Other things, even like this designing in the 3D view, having to create sections in order to do certain vertical things was very onerous to us
Mm-hmm.
as a bunch of AutoCAD guys. And so when we created these tools, we said, well, why shouldn't I be able to do these things in any view? Up
Right.
is up, down is down, left and right. So I just switched out this piece of pipe, and I wanted to point out the fact that just like Revit, I see this pipe as an individual piece between these two threaded fittings. And I
Right.
just told the system that this was a piece of 2.5-inch schedule. Well, actually, I didn't call it Schedule 10. I called it standard pipe. So if I run that same material summary process, which, by the way, the material summary call is exactly like the call for the stock list. The only difference is that my stock list report screen doesn't pop up on me. So everything that you see me doing here in order to run this process is exactly the same for generating a Sprinkcad stock list. And anybody that's familiar with Sprinkcad and the stock list process knows that it's all very responsive to those strategies. And we brought those strategies essentially right straight across into the Revit offering. All right, so I'm just telling the program that this 2.5-inch pipe that I just created is schedule 10, 2-inch, 2.5, and the 1-inch schedule 40 pipe that was on the system is indeed 1-inch schedule 40, and I run that, and then when I close and update that, the big difference here is now I've got to build a couple of more families. So the program kicks in, says it's going to build some families.
How easy is the transition, like when you're let's say you've got a system laid out like this line that you're working on right now, how easy is it to switch the entire thing from a cast iron threaded thread family to, say, groovelets or mechanical tees or anything like that? Is it just a matter of switching that family over and then it'll update the model automatically, or is it?
No, it's actually, I would say, easier than that.
Right.
The fact is that when you go into your strategies, so up on my Sprinkcad, I've got the hiding here from me. I've got my design areas, my job info button, job info, and it's actually reproduced across here somewhere else. When I jump into the strategy screen, all I have to do is say that this kind of pipe likes to have welded outlets
Okay.
or mechanical tees. So the difference between mechanical tees and welded outlets is that simple. What I did up on screen now, you'll see that the program just
There you
turned
go.
that branch line into a single piece of pipe. It inserted the coupling that breaks the pipe. Why? Because it's 2.5-inch schedule 10. It wants to have welded
It
outlets.
wants to be and it wants to be grooved. Yeah.
Right. And if I had told the program to use mechanical tees, you'd see a mechanical tee here instead of that pipelet. And so it inserts the couplings for me. And the reason that it put the couplings where it did was the program knows to put the long end of the pipe at the end of the run and work back toward the starting point. And earlier I told the program to start everything from down at this end. So in terms of ductile iron versus let's see, cast iron. That's a slightly different question because in both cases, the Sprinkcad strategy says, I like to have threaded fittings. The concept with our family, the concept behind our connection strategies is that the pipe talks to the fitting. If I tell the pipe that it likes to have threaded endpoints, then when it reaches a fitting, it's telling that fitting, I need a threaded outlet from you. And if two pipes meet at a 90 and they both want to be threaded, that's a threaded 90.
That's right. Yep.
Now, in the database, there are a series of preferred check marks where you can say, when the program wants a 1-inch threaded 90-degree elbow, I like that ductile iron piece right there by part number, by takeout. You can say, oh no, I want to use these malleable iron fittings, or I want to use this short radius groove 90 from some other manufacturer.
Right.
As long as you go into your database and specify, when looking for a fitting of this geometry with these end preps and these sizes, you say, I like that one, then the program will use it whenever you call for that stock list material summary. And you can save lists of preferred items. So maybe you're a consultant or a designer for hire, and you've got 3 different companies you work for. These guys like mechanical tees, these guys like pipelettes and ductile iron fittings, and those guys use somebody else's non-Tyco product. We won't work with them. No, I'm just kidding. We
We'll
support it.
tell them where to go.
That's
Yeah,
right. That's right. As long as they buy it from our distributor, okay.
Yeah, there you go.
But whatever you want as your standards, you just tell the database, this is the way I like it, and save that setup. Every time you use that setup, the program's going to draw from those fittings.
And it's going to work off of that. How, another thing that I know Sprinkcad has in JCI is kind of the owner of the kind of one of the most sought after pieces of technology in fire protection design is the fluid delivery time.
All right. So I'm going to see if I can real quickly pull up a fluid delivery time situation to show you. I'll go with a
Sure.
standard, just arm over and drop here. No, as a matter of fact, this might as well have some fun.
Yeah. Gooseneck
Uh,
it because you're going to have it on a dry system anyways.
Right, okay, and so I'm going to basically say now these items that you see, this screen remembers what I did earlier in the session.
Right.
So these are still set to 1 inch standard. My segment B vertical offset is a foot from the pipe. I'm not going to go to the sprinklers. And now this particular item, it says, okay, what's your minimum arm over length and what's your maximum arm over length? So I'm going to bump this down to 2 feet. I'm going to tell it that the branch line, the actual branch line that we're going to create, wants to be 1 foot higher than the main. And I actually
Okay.
have an option here that I could reference the main's level. That's a Revit level. So if you had a sloping main, but you wanted all your branch lines to be at 9'9", then I could say, I want my branch lines to be 9'9" above the main pipe's level. And then every riser nipple would be a different length. Branch to main connection, 1.5 inches. Okay, so I'm gonna run this. I'm gonna grab a bunch of sprinklers. Now I'm running this in the fine mode as opposed to if I was running it in coarse, I could see those sprinkler heads. But basically I grab the sprinklers, I grab the main, and I get this image that shows me this is how they're going to get routed. And I might look at this and say, well, I don't really like some of this. I'm gonna increase my maximum arm over length to 3 feet and refresh that, and I get a slightly different layout. Or I want to flip those arm overs over to the other side of things. It's kind of arbitrary when they're all broken up like this, but if it was a very regular system and you just wanted everything on the left side, etc., that would, that'd be more meaningful. So I run that. Takes a couple seconds to draw all those
Sure.
pipes.
And basically what you've just done is highlighted a wing of a building and kind of asked, I mean,
Yeah, I
you
select a
made it
bunch
do
of
it.
I
And
select a bunch of
you made it,
sprinklers.
yeah, you made it draw the piping
I
the
got all
most
the branch
efficient way.
lines. Yeah.
Yeah.
Yeah, and you know what? You said the most efficient way, and I want to be fair. The program can only understand so much of what is or is not efficient. There comes a point where you're going to have to modify a few branch lines and move things, but Revit does make that easy. Once the connections are made, it's not hard to slide a branch line over 6 inches or put a jog around or things like
Right.
that.
If it made the job too easy, you probably wouldn't sell too many because no designer, all the designers would be out of work, right? You'd sell them to the companies and not the designers themselves.
All right, so I'm going to switch over to kind of a 3-dimensional isometric view, and you can see I just basically created all these goosenecks tied into all the branch line mains. What I'm going to do in order to show you that fluid delivery time is I'm going to ask the program to just send this whole system into the Sprinkcalc program.
Right.
So I say proceed to Sprinkcalc. It asks me to map my piping, just like any other condition. The program needs to know, well, what exactly kind of pipes are these? And again, I'll point out that you could be drawing using somebody else's software. You could be drawing using straight Revit. You could get a drawing from somebody else who draws in straight Revit and has their own pipe types set up. Our program will read them and let you map them to known pipes within our database. So this is 4-inch schedule 10. I've got 1.5" schedule 40. I see 1.25" schedule 40.
What a mean designer, 1.5" skid 40.
And then, oh, you don't like that, huh?
Groove it if you can. No, I'm just kidding.
Yeah, well,
I
that's
like
true. You
threading
know,
pipe together.
when I started, 2" and down was threaded, and then over the years that has slowly crept down.
Yeah.
And I think it was the improvement of groove fittings, quite honestly, but
Mhm.
groove couplings. Anyway, the program
Now
already.
you're even starting to see people not even using, like 1.25" is almost, people aren't using it anymore
Oh
because
yeah,
of
they're just skipping over it.
just going right to 1.5".
Yeah, yeah. Let's see, that's a 4" alarm valve, and this is a gate valve. So you'll notice I'm able to go up here and do a little sort. I'm
Mm-hmm.
honestly, I'm hoping to improve a couple of these dialogues yet, but those things take time. We got to kill the big fish first. Or wait,
Yeah.
let's not kill the fish, let's catch and release.
So it's like what we're looking at on your screen right now. If you're not watching it, or if you haven't shut off the podcast and switched over to YouTube yet,
Yeah.
is if you're looking at a video game, is essentially the best way of putting it. You're looking at a video game, and I mean, boy, if we had these video games when I was a kid, uh, you're looking at a video game of a sprinkler system, which is awesome. And so he's just working through creating the files right now for the Sprinkcad software right now, so it can kind of go through and get your fluid delivery times.
Right, so the calc program is part of your Revit. So I didn't run a calculation, but if I had basically gone in and said, these are the sprinkler heads that are flowing in design area 1, these are the heads that are flowing in design area 2, you can insert hoses, you can specify the source conditions, the whole 9 yards, standpipes, everything, whatever you can do in our calc program. You could do that in Revit and it'll run those calcs and you'll get a result. What I did here is I took the system and I sent it into the calc program, not as individual design areas, but just like send the whole thing in, because fluid delivery time needs the whole system. It needs to know the volume of those pipes in order to understand the compression of the air and the movement of the water through the entire system.
Okay.
So I'm saving this file into my Calc 4, I'm going to call it demo FDT so I can find it later. And if I wanted to, I mean, I could right now, I could go in and run calculations in here, but the truth is it's much easier to perform basic hydraulic calculations right from the Revit interface, right from the CAD interface, as opposed to running Sprinkcad. Even though there are many authorities and insurance companies and people who do run Sprinkcad strictly for hydraulics, for the designer, I'm going to say, no, don't waste your time. Do that from your Revit environment.
Right.
All right, so now I'm going to minimize Revit. So now that I've reopened in the calc software with the fluid delivery time license activated, I can now go in and I can grab a hold of specific sprinkler heads, and I'll just take like these 4 down here.
Mm-hmm.
And I'm able to say, let's create a headset. And it says, well, you can't do that for a wet system. All right, so that means I've got to come in here and I got to take a look at my valve.
So it's understanding the type of valve you have in order to do the fluid delivery time. It's seeing that you have a wet valve installed and cannot do a fluid delivery time. Fluid's already there.
And while that's generally true, yes, the real issue was I had not told this system that it was a dry pipe system, because that alarm valve is capable of acting as a dry valve. So now I flipped over this other switch that says this is a dry system, and it says, hey, all these things are going to be updated, and I should now be able to grab a hold of, with my node selection tool, grab a hold of 4 heads. And I say 4 heads just because the standard in fluid delivery time is 1, 2, or 4. And that comes out of UL, and it says, okay, you need a supply node. All right, so now I've got to go down here and grab a hold of that node and tell him that he is of the type source. or supply. Now, in order to actually run a fluid delivery time calc, that supply has to have parameters or a curve. Right now, that's an empty source, but I have the ability to come in here and say, let's just grab a hold of a pump that I have in my database. So horizontal split case, and you know, it really doesn't matter which pump I grab right here. Obviously, a user is going to pick something meaningful, but what matters is that I now have this flow curve that represents the power of my source at that point. And I say, okay, and back out. Let's see if I can actually get a fluid delivery time calc started now. Node selection tool, grab 4 heads, and tell it I want a new headset. And it says that you don't have a dry pipe valve. All right, so my bad. So now I've got to come in, take a closer look at that valve.
So this is where it'll be able to tell you, no, you can't. That's a wet system. Or a
Yeah,
wet valve. Yeah. Okay.
right. So now I'm in here and I have to specifically tell the program it's a dry pipe valve. And so looking, alarm valve. Now somebody out there, such as Derek Tyler, is right now screaming into the radio, you know, or the
It's
computer.
right there. It's
Right
right
there, Rob.
there.
Subtype alarm valve 52. I know that I got that wrong, and I'm looking for, it's not
The
a
dry
generic.
pipe valve family, or
Yeah, it's here somewhere. Come on, baby. Now this is where I count on you, Chris, to actually edit out all this
oh, no
nasty
problem.
looking around stuff. Yeah, am I on the wrong part? I don't
As,
think so.
as far as
Alarm
anybody
valve.
knows, it's going to go right from, then I got to click here and select dry pipe valve, and then that's where it'll
Right.
go.
Ball valve, gate valve, pressure relief, alarm valve. Well, I'll be darned. What did I do wrong here? All right, tell you what, I'll bet the issue is right here. Hydraulic group. Yes.
GPV. Yep, there you go.
All right. So I have to tell my valve that it is indeed a dry pipe valve. And then I can pick a specific device, and the program will offer me this list of dry pipe valves. So I'm going to
Hey,
grab
there we
like
go.
DPV, and I just grab one at random here. I'm a bad salesman.
The
I must.
DPV1 is probably one of the best dry pipe valves out there.
Okay, good job.
That's not me just kissing JCI's rear end.
Okay.
My favorite dry pipe valves.
You know, I'm terrible because I'm such a Sprinkcad oriented guy. I've got my head in how the program works. I just don't pay a lot of attention to product, and I probably shouldn't admit that with, you know, people from product on the line, but what are you gonna do? All right.
It's okay. We got
So
him muted. It's fine.
now, you know, this is a dry pipe valve. I accidentally picked a 3-inch valve. That's okay. I have to specify a trip ratio because fluid delivery time is very interested in how long does it take that valve to open based on the gas pressure in the system, based on the volume of gas in the system, based on how many orifices open up at a given moment. And of course, that's all covered by NFPA 13 and the UL listings and stuff like that that tell you how many heads you have to open under certain conditions. Is it a residential system? Is it commercial? Is it, et cetera?
Right.
There's also optional accelerators that can be activated, such as our electronic accelerator and other companies have similar devices, so that as the air begins to bleed out of the system, instead of waiting for that air pressure to drop to the point where the clapper, quote unquote, releases due to the difference in the pressure under the clapper versus over the clapper, you can have a device that says, hey, I sense an air pressure loss. And there are various ways to define those devices based on manufacturer and model. But essentially what it does then is it allows the valve to open sooner.
Right.
So you have pressurized water entering the system, and the gas pressure in the system has not gone down as much. And that's one of the things that this program actually taught people that they didn't expect, is that having more gas pressure in the system wouldn't slow the water from entering the system. It would actually limit the amount of water that moves into the non-active portions of the system,
Oh,
because you
okay.
get this air pressure buffer.
Right. So
So
with a higher pressure, you have more air in the lines that are not discharging.
right.
Yeah.
And so that funnels the water into the more important areas of the system
Right.
that much more quickly. Now, having said that, everything is subject to specifics of the topology of the system and you know, the actual layout and how much of this and how many feet of that.
Yep.
But that was a general rule that a lot of people didn't expect when they implemented this software. Okay, so now I've modified that pipe's properties, valve, I should say, and I'm going to come up here and tell the program I really, really, really want to make a new headset, and it does. And based on some defaults, I can come in and change these, but the program says, okay, you got a bunch of 5.6 K factor heads, and the operating pressure is set for 7.2 PSI.
Okay.
When I go to run a calculation, I have a trip time, a delivery time, and an operating time. So trip is how long does it take for the valve to open?
Right.
Delivery is how long did it take for the valve to open and for the water to get to the operating sprinklers, which is basically where the inspector clicks the stopwatch. And then
Right.
we have this third feature, which is how long does it take the pressure to reach full operating value at all of your sprinkler heads. So it could take a few extra seconds for the
Mm-hmm.
back pressure to build up and everything operating at full capacity. I've got questions like, what's the gas pressure? So I'm going to drop in, 15 PSI. I won't go down this road of discussion, but there are some who say that low air pressure systems are better because, et cetera. I'm just going to say that that's not always true. You
Mm-hmm.
really need to run, in fact, I'll say I don't think it's very often true personally, but you need to run the calculations and really prove out under your water pressure conditions, under your system layout, under the possible valve types and system that you might install, what's going to operate. You'll see that there's also a gas temperature, because the actual air temperature has an impact on how quickly that air can escape through the open orifices. There's a monitoring time, required delivery time. I'll leave those go. And I'm going to say I don't have an accelerator, and I'm just going to basically run that. And it says, hey, your gas pressure is too low to hold back that. Now, I told the program that my valve had a 5.5 differential trip ratio. I didn't bother to look at how strong my source was, so I'm just going to bump the gas pressure up a couple of times. I bumped it up to 25 PSI, calculations completed successfully. And if I look at my summary, it'll tell me that it took 1.7 seconds for that dry pipe valve to operate.
And
All
then,
right.
so now going back, how do you get the water delivery?
All right, so basically I click that button right there and I run it again, and the program's done. And now I can look at that summary, and it says, okay, took 1.7 to trip, and it took another 7.5 seconds for this water to hit H13, or head number 13.
Wow.
And then the last one would be to run the operating pressure if you care about that. But if I run the analysis screen, what you're seeing here are up to 6 important points in the overall system. Top left is the source. The next one to the right is the dry pipe valve, and then we have these 4 sprinkler heads. So at the source, the red line is my pressure. The source pressure was about 105 pounds static, and it held there for that 1.7 seconds, and then it dropped down to somewhere between 40 and 50 PSI, and then the pressure slowly starts to climb, and you'll see a little dip, or I should say a jump in the pressure as the water begins to equalize into the system. For those first, what is that, about half of a second to 1 second, that water is just rushing in as fast as it can get past that valve. Then you start to get back pressure. So same thing with the blue line is water. There's no flow until the clapper opens, then a whole lot of water, and then it slowly begins to decline. In fact, what I'm going to do is I'm going to close this and run one more. I'm going to run the operating, because that has more interesting graphs. Take a look at the analysis. So now, what we saw before was only the first 7 or 8 seconds and everything stopped.
Right.
Now we have all the way out to about 16, 17 seconds, at which point, and you can see on the sprinkler head charts, top right and bottom 3, as the air pressure and the water flow, they all equalize out. And you see those little wiggles. That's the air pressure acting on those dead end portions of the system, and you get that water coming in, and pressures are balancing, equalizing, till you get a very steady condition.
Is that the water stabilizing, like water pressure stabilizing as well? That's when you get your peak flow.
Yes.
And okay.
Yes, and if I close this and I run this little movie, then we can actually watch the water run into the system. So I'll hit play, and it splits again, and it hits those 4 heads. And now you see the water continuing to push in and fill portions of the system over those many seconds. Now, the program, everything from the moment the water hit the heads, right about here, on out, this would be considered fluid delivery time, 7.3 seconds. The rest of that time is, did the pressure stay above the minimum pressure for a total of 10 seconds? Those are the defaults built into the system.
Okay.
I've worked with people where they had to extend that out further to give the program more time to equalize and set out the pressure because of crazy large systems or whatever reason. But what's interesting is as I move the mouse between the or move the cursor between the 7 and the 17, you can see how things are kind of expanding and contracting.
Right.
And it's a little slower here in our view than when I'm running it all by itself. But that's basically water pressure building at the heads, the pressure is equalizing, and all that extra piping and air acting as a buffer to the pressure buildup. And that's fluid delivery time.
That's fluid delivery time.
And let me point out that the real advantage of fluid delivery time, in my opinion, I think it's a fantastic program because it can save the contractor so much money.
Absolutely.
Not only in the concept of, I know it's going to work before I go out there and pull that flow test, but also the fact that by standard thinking, people used to put in 3, 4, 5 dry pipe valves where they can now come in and put in just 2 or 3.
Right.
And the amount of money saved on the valve and the labor, honestly, you have to wonder, why did Johnson Controls make this piece of software? Because it's losing them money.
Yeah.
But it does work to the advantage of the industry.
It's an awesome, thank you for showing me that. If somebody wants to come on and do a trial or learn more about the fluid delivery time or Sprinkcad itself, where do they go for more information?
Sprinkcad.com is the web page, and right up across the top in the right corner is a big orange button that says sales/demo. And pretty much all product requests, all information requests. You click that button, it brings you to a page that says, if you're in the Americas, use this email address. If you're in Asia Pacific, use this email address. If you're in Europe and Middle East. So you click on the appropriate email address and just write the email and explain what you want. I mentioned at the very beginning that we'd love to have feedback from people that are designing in Revit and feel the need for specialized tools that meet their needs. I've found that there are not so many people designing in Revit that it's easy for me to get feedback on what's next. What do you really need? One good question is, how important is it? We do hangars, but I've been thinking it'd be nice to have some automated hangar routine. So I'd love to hear, what are your pain points? What are your needs in that Revit environment? Use that email link and just in there indicate somewhere like, feature request Revit, and then explain what you're looking for, and somebody will get back to you.
Thanks for showing me the Sprinkcad for Revit.
My pleasure.
A lot.
Yeah, I wish I'd have been able to even show you more of the tools, because there's so many cool tools in here, but we got carried away.
That'll be for another episode.
I'd love it.
Awesome. Thanks again.
Thank you.
Hey everyone, this episode of the Fire Sprinkler Podcast is done. If you liked this episode, leave a review, comment, or hop over to my social media pages and let me know. Just search Fire Sprinkler Podcast on Facebook, Twitter, Instagram, or LinkedIn. Don't forget to hashtag Fire Sprinkler Podcast and anything you think I should know about or see. If you have any suggestions for future episodes of the Fire Sprinkler Podcast, email info@firesprinklerpodcast.com. Thanks for listening. We'll see you next time. Take care.